hear the word titration, you must think of this experiment that we did. Guys, I bought a new packet of highlighters a week ago. There's 2 classes that use my highlighters. Your class and the grade 12 English class. 2. So between the 2 of you, I've lost 4 highlighters in a week. In a week. Don't just blame Khali. Khali? I'm very serious. Like, I'm not going to buy new highlighters. It can't be a week. Normally, the previous packet took me 2 years. 2 years before it was all gone and finished. How is that possible? Okay, so acid-base neutralization reactions. I told you these 2 words almost go hand in hand. Titration is just this process where you add the 2 things together. So if I just, like normally, not with this, do this, if I just add the acid and the base together, yeah, then it's still called an acid-base reaction. But if you do this process, it's called a titration reaction. Okay. Right, then, like I said, it's a reaction between an acid and a base. Then, the pH does not have to end at 7. Neutralization does not mean that it is completely neutral at the end. Neutralization just means for every hydroxide ion, there is an hydrogen ion. Okay, let's pretend 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. No, we don't have to pretend. We can say this class has today equal amount of boys and girls. Okay, so for every boy there is a girl, or for every girl there is a boy. Does that mean you will all like find your partner in this class and marry them? No. Okay, you don't have to answer that quickly, but no. Right? You can, it's possible, because for every boy there is a girl, but that does not necessarily mean you find your partner here. Same thing. In an acid-base reaction, when we call it a neutralization reaction, it means that for every hydroxide there is a hydrogen present, but that does not necessarily mean they will bond with one another. Okay, so the pH does not necessarily end at 7. The pH is dependent on the strength of the acid and the base. If it is a strong acid, it will ionize completely. If it is a strong base, it will dissociate completely. And then, yes, the pH might be 7. But that does not necessarily mean that. And then the end pH indicates the choice of indicator that we will use. Okay, like we just discussed here. Then you have 2 points. You have equivalence point and end point. And they do overlap a bit, but they're not the same thing. The equivalence point is the point at which an acid has completely reacted with the base. Completely meaning for every hydrogen there is a hydroxide ion and they did find each other. Okay, so they are all finished, complete, used up. So every hydrogen ion has an hydroxide ion. The end point is the point where the indicator changes color. Okay, where the reaction is completed and it will not go further. Can't go further. Okay, so here what we just did is in 2 graphs, what we just did here in front. Okay, you can see this is a graph where we have pH versus the hydroxide ions. Okay, they say here you have a strong acid like hydrochloric acid. And here we have sodium hydroxide. Khali, strong or weak? Strong base. So we have a strong acid, strong base. So Lesedi, which indicator will be suitable for this reaction? Yes, bromphimol blue will be suitable for this reaction. Okay, now as you can see here at the beginning, there has been 0 sodium hydroxide added. Okay, so this was at the beginning, I only had the Adelaide matte flask with the acid in. I haven't added any of the base there at the top. What color will it be there when I only have the acid? So yeah. No, we are at broomfimel blue. Broomfimel blue, and it's only the acid. Yellow. You guys remember it was yellow? Yes. Okay, and you can see the pH is very low, and that makes sense because we only have that strong acid. Then we slowly added the base, added the base, and then at one point, that one drop caused it to change color. That one drop caused it to be at equilibrium. What color was it when it was at? No, green. It was green. The pH will be around 7 because it's a strong acid and a strong base. And then that one drop caused it to become what? Blue. So there where it was yellow, it was an acid. There where it was green, it was neutral. And there where it was blue, it was a base. Yes? Okay. Then, if we look at the titration between a weak acid and a strong base, the first experiment that we did, I used ethanoic acid. You remember? Okay. Now, ethanoic acid is a weak acid. Sodium hydroxide is a strong base. Tato, which indicator will be suitable? Weak acid, strong base? No, weak acids, yes. Phenol, I'm going to abbreviate now. Tell you. Okay, then, Cloney, when we started with no base, zero base, it was only the acid. What color was it? Colorless. Can you see that the pH is a bit higher up than this one? Why? Because it is a weak acid. This was a strong acid. So the pH is a bit higher up, but it's still an acid. Then we slowly added, and then it changed to what color, Kutlano? It changes here to light pink. And then when we added too much, it was a dark, or a bright pink. Cha? There's the pink. Pink, purple, Barbie pink. It's a color I don't wear. Okay, right. Now we're going to do calculations because I told you the aim of this reaction, this experiment, is to calculate an unknown concentration. Okay, so to calculate that unknown concentration, we're going to use this formula. Now, that equal sign must not be there. Okay, so in this equation, you can see there's an acid with a base. Now this is not a typing error. That thing there in front is the coefficient that we use. For example, if we have sulfuric acid that reacts with sodium hydroxide, then the mole ratio is 1 to 2. You need 2 sodium hydroxides. Okay, so that A and B is that 1 and 2 there in front. It's the coefficients. Okay, that's what it just represents there. Right, so in this here, from there we draw this formula. In this formula, this N there is the mole of the acid, mole of the base. Now, as you can see, it's on a fraction, and a fraction gives you a ratio. So this whole formula is a ratio between the acid and the base, and what do you get, and what do you use, and what. Okay, so this here is a ratio formula. On the left-hand side, we have mole and mole, and that mole there represents your theoretical mole. Your theoretical mole. And where do you find your theoretical mole? You find it in your balanced equation. So you find that in your equation. Sure? Okay, so that mole there is that 1 and 2 that we have here. Okay? Then this thing here on the right-hand side is concentration times volume. Now, we have two formulas that calculate concentration. Concentration is mole over volume, or concentration is mass over molar mass times volume. You remember that? Okay. So, if I take this formula and I rearrange that, then I get mole is concentration times volume. Yes? So, what I basically have here, the concentration times volume. So concentration times volume is the mole. So what I have on the right-hand side is your actual values that you've added. Like if we measure off how much, what is the concentration? So not in the balanced equation, it's your actual values that you've used. So it's your actual values, and it's actually your actual mole. Because concentration times volume is mole. Okay, so like I've said, this is a ratio formula. It gives you the ratio of the acids relative to the base, how much you use, how much you get, and. Okay, let's look at an example. It says, in a titration, is neutralized. Now, if I say acid, you say? If I say base, you say? You don't say drop the base, you say? No. Simple? Hydroxide ion. Okay? Now the next thing that is stuck in your head until you die of the day. Okay? Yes? Is if I say titration, if you read titration, you must immediately think of this formula. Okay, so if you read somewhere, in a titration, blah, 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 immediately you think, okay, I think I'm going to use this formula somewhere, somehow. There is another way to do this calculation. So again, if you have extra classes somewhere else, or past papers or books, and you see another way, that's fine. There's a million ways. I just use this way because everything is together. Okay, right. So if you read titration, you think of this formula that will be on your data sheet. Okay, so they say in a titration, so much of sulfuric acid is neutralized by so much potassium hydroxide. Determine the concentration of the acid. Okay, so we don't know this concentration. You start with your info table. You're going to have mole, acid, mole, base. Concentration, acid, concentration, base. Volume, acid, volume, base. Zara, give me any information I can put in here.
The volume of the acid
Is?
12.3 times the volume.
Okay, so this acid is 12.3. Volume of acid, 12.3. And like she said, it is centimeters cubed, and we don't work in centimeters cubed, so times 10 to the power negative 3. Okay, simple. Anything else? Say again? Where does that go? Doesn't go? What does VB stand for? Yes, so you should know this and this information is regarding potassium hydroxide, and potassium hydroxide is a base. How do you know that? Hydroxide is a base. Okay, so that is the volume of the base, 20.5 times 10 to the power negative 3. Khali? Another thing that I can add? The concentration of the base is 0.3. And they ask, determine the concentration of the acid. So there I put my question mark. Now let's see, where do I find these things? No. Call a friend, ask the audience 50-50. Audience, Rory. By the balanced equation. Now, do we have a balanced equation? No, we must write down. Okay, so Sia, take us away. Sure. What's the first thing that I write down? Yes, but in the equation. What do I have? What reacts with what? Okay, sulfuric acid reacts with? Now, what does that look like? Okay, KOH. Okay. So I quickly see ma'am is calling me. Rory, are you going to tell us what we get in a moment? Hello? Yes. Alright, bye. Sorry, yes, Rory? The rest of you, are you also figuring this out? Yes. Yes. Okay. Potassium sulfate, like that. Potassium's valency is? Sulfate? Don't look on there. -2. Okay, so is it fine like that? +1 and -2. No. When you write a formula like this, there should be no negative and positives. Okay? It will be K2, yes, plus water. Hope, is this balanced? What are you going to do? Say again? Where? Down. I'm asking. What else? Say again? Shh. Two potassiums. One sulfate. 2 plus 2, 4 hydrogens. All right.